So that's FA. I just do this, and do that. FF, FN, F. Oh, whoops, just kidding. Yeah, that's weird. Yeah, okay. There you go. That arrow's in the wrong direction. That arrow's just in the wrong direction. Is like this person would be slowing this box down. Is this. Okay, so that's fine. That's right. Okay. With that said, and recorded and everything, so everybody knows, this arrow is supposed to go that way. So it just got flipped when I printed it out. Okay, because, yeah, so then at this point, like that, like it's supposed to be like you're pushing it, it's going at constant velocity. And then this was what it was supposed to be. G, F, F.
What's that big arrow? It's now confused.
This one?
Yeah.
That's FA.
Oh, okay. It's F is way up there.
What's that?
F is like up there, it's not close to the arrow.
Oh,
Just
yeah.
FA.
But does that make sense then?
Yeah.
Yeah. I think when I printed it out, it didn't look right. But okay, so then this is what's supposed to be there. And then the force of friction, so you got to find this. So since it's constant velocity, some of the forces in the x is 0, some of the forces in the y are 0. Say FA is equal to FF. I can say Fn is equal to Fg. And then we know that F, yeah, okay. We know that FF, what is the force of friction? Actually, yeah, it doesn't matter. We could have just said this is 300 newtons. Technically, if you just wrote that, you're done. So it's kind of like a trick question. No, not a trick question, but. Now, what I do want to show you is here. If I said FA equals FF, which is mu F sub n, right? And then I can plug in the mg, which gives me mg. You need to be able to do that. You need to be able to recognize that this all works out. So FA is equal to this. So what you can get from this, that, well, yeah, sort of. But yeah, be able to do this. So what I guess what I'm getting at is be able to come up with mu, is that you might. Okay. Take this, go up here, and then we say, starting from rest and applying 400 newtons. So this time we're applying, if you assume the same friction, then what is the force of friction? Yeah, 300. Right, remember F sub F is 300. Okay, what is the acceleration? How long would it take? So if I look at some of the forces in the X is MA, then I have FA, remember, minus FF equals MA instead of 0. So A is equal to FA minus FF over M, and that's going to be 100 over 30, so it's like 3.3 meters per second squared. Am I done? No, that's just part of it. Now, how long would it take you to push the box 5 meters? And it's saying, assuming starting from rest. So we say x equals v0t plus 1/2 at squared. That's 0, because it started from rest. So t is equal to the square root of 2x over a. And then that means 10 divided by 3.3333, which is 3. So the square root of 3, which is like 1.62 or 1.7? 73, sorry. So 1.73 seconds. Then, if you release the box, when you get to 5 meters, how long will it take to stop? So we've got this thing going, velocity, right? So we pushed it for this long at this acceleration. So v is equal to v0 plus at. So v0 was nothing, so that gives me 1.73 times that, which is going to be like almost what, 5 point something, 6 or 7? Or what do you get? Or is it? It's not 6. It might be 6.
5.76.
Oh, okay, if I was right the first time. 5.76 meters per second. That's important because we need to know this to figure out the stopping. And then the next part is, in order to know how long it'll take to stop, we need to know how fast it's decelerating, right? So if I look at the sum of the forces in the x, it's ma that's caused by friction. I called that something different because I wanted you to see there's a difference, right? So then this, the only force here is F sub F, and that's going to equal AF. And do you remember what F sub F equaled? We discovered it up here. We said F sub F was equal to mu mg, right? Okay, so then that means this is mu mg equals ma sub F. That goes away, and we get A sub F is mu g. So now I can figure it out. How long will it take to stop? We can do the same thing, but backwards. So if I use V equals V0 plus AT, what is V going to be? 0, right? Because it's stopping. So then, oh, and also this is going to be a negative, so then T is going to be equal. So if I move this over, I'll get, or move this over, I get negative V0 over A. So then V0 is negative 5.76 meters per second over, did we figure out? Oh, okay, sorry. This is 3, we're going to have to do, I forgot, I thought we already solved for me. So A sub F is going to be negative F sub F over M, right? So then we'll get, F sub F was 300, remember that? And then 300 divided by the 30? Yeah. So 300 divided by 30 is 10. So we get, that will give us, sorry? M? Sorry, bad writing. So that's going to give us negative 10 meters per second squared. So we go negative 10 meters per second squared, and then that's going to give us 1 point something seconds. Or no, not 1 point, like 0.4 or something like that. No, 0.4? No, 0.6, 0.57, whatever, 0.57. Good gravy. Look at that, divide by 10. My brain went south. It's obviously just move the decimal. So we get 0.576 seconds. Okay, now the good thing is this test is not for 2 more days. So let's take a look. Okay, so if you need to go back, it's fine too. Let's take a look at this thing overall, because this is going to translate to everything else in the year. On a scale of like 1 to 5, how difficult was this, assuming that this arrow was in the right direction? Well, actually, even if it wasn't, right? On a scale of 1 to 5, how difficult was this force diagram? Okay, this was, you wish that the force diagram, force quiz had this on there, right? It's ridiculously easy. How about this one? 6? Just writing 300, that's all you had to do, was realize that the forces were equal and opposite. Boom, done. Okay, so I think this was a 1. Okay, what if I asked you to come up with mu? It would be around like a 3 or something, right? Okay, down here, what about this one? Okay, this one is more difficult, right? Maybe I'm shooting for like a 4, because now I'm asking you to do something not that difficult from this chapter, but then I'm asking you to bring in last chapter too. You see what I'm saying? And then this one, is like multiple steps using everything that we've learned. This one is comprehensive. And this is the structure of the test just about every time. I will try to shoot for like a 1, then or a 2, then a 3 or a 4, and this one is always like a 4 or 5. I'm always trying, this box will always be like, can you put together everything you've learned? So when we're in electricity and talking about power, I might have something that involves the battery that runs for a certain amount of time. Running that time, the distance of travel, the speed of travel, and use that to go. And then this will always be like, have you been awake in my class? This one is, have you been doing your homework? This one is like, did you study well? And this one is, do you understand physics? Okay, so that's how it goes. Test is multiple choice. And the multiple choice don't ever hit this. They're all around 2 or 3. That's the idea. The multiple choice is more like, did you study for the test? And if you did, you should be able to do simple calculations, one-step calculations. You should be able to do simple, like if you're combining ideas on the multiple choice, it's pretty straightforward, 2 simple concepts put together. So the multiple choice is supposed to like be, did you study? Do you know the concepts? Do you know the formulas? Right? And well, you don't even have to memorize them. They're all on the formula sheet, which you're allowed to use during the test. But this part is designed so that this one is for people who can get A's. So yeah, that's basically how it works. Any questions on how the test will run in that respect? Okay, so then the question is, did you want me to give you time to work in your groups? Or did you want me to make up extra questions as if I was designing another test?
Question.
Should we work in our groups and make questions so we can take how to do it?
You can do one over, I don't care, that's fine. So how many would like to work in groups? 1 person. Okay, well then we'll, yeah, we'll do this then. You know what? Yeah, that's actually, has a good idea. Let's get in our groups, and then I will throw some problems up, and you guys can work on it. All right, so let's go.
Okay, now,